Big Soft Ed presents Chunking. What is chunking? It's not an honorary title for Jackie Chan.
Hey, chunking! Captain Chunk!
And it's nothing to do with the Goonies.
Come on!
What it is a pen and paper method for working out division problems.
Come on!
I'm afraid so. Division problems are questions like, what's 154 divided by 3? How many 14s are there in 498? 23 pirates share their hoard of 5,000 doubloons. How much does each pirate receive, and how many doubloons are left over for them to fight for? You can use chunking to solve any of these. Or you could use a calculator. But what's the point in that?
The point being a cutlass.
You might hear critics of chunking say you shouldn't bother with it as it's not as fast as long division. But that misses the point. To some extent, chunking is a beginner's method. Complaining about its speed is like saying to someone learning to ride a push bike, you'd go a lot faster on a Harley Davidson. Well, yeah, you would, but not for long. Not only that, with enough practice you can solve problems with chunking at similar speeds to long division. Chunking also has at least two advantages. The first is that it's easier to see how it works. Long division is more mysterious, which can make it trickier to learn. I'd bet hard-won doubloons that many long divisioners don't really understand how their method works. The second is that when you use chunking, you get to decide the level of difficulty. You can solve things slowly but with easy calculations, or fast with harder calculations. So you can solve the same problem in several different ways depending how confident you are. In contrast, long division solves the same problem the exact same way every time. How boring is that? Where chunking falls down against long division is that it can't easily be used to work with decimals, either in the question or the answer. But if you're dividing to that degree of accuracy, you're better off using a calculator anyway. To appreciate how chunking works, we should take a look at what division is.
What division is?
To talk about dividing, we need to look at its opposite, multiplication.
What multiplication is?
Specifically, how multiplication is related to addition.
What addition is?
No, this is still about multiplication.
What multiplication is?
Thank you. Imagine you start with nothing. And by nothing, I mean 0. Now let's say we add 4. Several times, until we get to 20. Rather than write out all those add 4s, we can instead write that there are 5 lots of 4. And lots of means multiply. We've repeatedly added 4 5 times and got 20. For this reason, multiplication can be called repeated addition. Division is the opposite. If we start with 20 and repeatedly subtract 4 until we get back to 0, we'll have to subtract 4 5 times. This repeated subtraction is what we call division. And repeatedly subtracting is what you'll be doing with chunking. Now, what would have happened if, instead of dividing 20 by 4, we divided 23 by 4? We can still repeatedly subtract 4 5 times, but we can't get to 0. This time we have 3 left over. Subtracting another 4 would take us into negative numbers. And we don't want to go there. Not with chunking. The leftover piece is called the remainder. What you do with it depends on the problem you're solving. You might turn it into a fraction. Or a decimal. You might round your answer up. Or round it down. Or you might just leave the remainder as it is and include it in your answer. That's what we're going to do here. In summary, whenever you have a something divided by something else problem to solve, think of it as asking, how many times can you subtract the second number from the first, and how much is left over? Okay, you waited very patiently, or you just skipped ahead. So let's see how chunking makes use of this idea of repeated subtraction to solve a division problem. Imagine you and 2 others wish to share this large bar of chocolate. That's 154 squares shared among 3 of you. How many squares of chocolate would you each receive? Now here's an interesting aside. If you had this same chocolate bar, but instead wanted to give 3 squares to as many people as possible, how many could benefit from your chocolatey largesse? You might like to pause the video at this point and think about why those 2 different situations require the same calculation.
Pause for thought.
So there's 3 of you eager for a chocolate chowdown, but first you have to divvy up the squares. You could start by snapping off 3 squares, 1 for each of you. And you could keep on doing that, repeatedly subtracting 3 squares. But with such a Willy Wonka sized bar, that's going to take a while. Here's where chunking comes in. Instead of just snapping off 3 squares at a time, you could take off a bigger chunk. The size of that chunk is up to you. The only restriction is, since you're dividing by 3 in this case, the number of squares in the chunk must be in the 3 times table. So you could break off 30 squares. That's 10 lots of 3, which means it's exactly the same as taking away 3 squares 10 times. But you've done it in 1 chunk. That's left 115 squares. If you take away 15, which is 5 lots of 3, that will leave you a nice round 100 to continue with. Remember, the size of the chunks is up to you. The point is to keep subtracting until you can't take any more away. Instead of continuing with this unfeasibly large chocolate bar, let's look at something you can use to help you practice chunking. We're going to complete the Cocoa Conundrum using this software, which is available for free from the Big Soft Ed website. There's no set way of writing out the chunking method, so you can either follow the layout the software uses, or, even better, make the method your own and record things your way. The question is on the right, and we're going to do the working out on the left side of the screen. At the top we have how many squares of chocolate we have left to share out. We'll start the same way we did before, taking just 3 squares off at a time. Each time we need to record how many 3s we've taken and how many squares are left. We then took our first big chunk, 10 lots of 3, which is 30. That left us 115. By the way, if you're happy that lots of is times, you can change the way it's shown in the settings. Just because I like round numbers, we then took away 5 lots of 3, which is 15, leaving us with 100. Let's be daring and take away another big chunk. 10 lots of 3 is 30, so 20 lots of 3 must be twice that, 60. Remember, you get to choose the size of the chunks. By taking bigger chunks, you'll get to the answer in fewer calculations, but they might be more difficult. Smaller chunks normally mean easier calculations, you'll just be doing more of them. We're down to 40 squares. Take off another 10 lots of 3 to leave us with 10 squares. 3 3s are 9. And now we have just 1 square left. It's less than 3, so we can't take any more away. 1 is our remainder. The last thing we have to do is add up how many lots of 3 we took away. That's the purple numbers written up the left side here. The 20 and 2 10s make 40. The 3 and the 5 make 8, so that's 48, 49, 50, 51. And we're done. 154 divided by 3 is 51, remainder 1. You and your 2 friends get 51 squares each, with 1 left over. If you were watching all that and saying something like, "It's taken you ages to solve that. Come on, 3 50s, 3 1s and 1 left over," you might be happier with a tougher question. So what about those 23 pirates and their 5,000 doubloons? Try to take chunks that are easy to calculate with. We could start with 100 lots of 23, 2,300. But that would leave 2,700, which means we could have taken away twice as much. So another good tip is to look for opportunities for doubling. Let's do that instead. 200 lots of 23 is 4,600. That leaves 400. Take off 10 lots of 23, leaves 170. 2 23s are 46, leaving 124. The current remainder isn't an easy number to work with, so I'll just take 123 off to leave 101, which is slightly easy to subtract from. Another 2 23s leaves 55, and another 2 leaves 9, which, being less than 23, is our remainder. In all, we subtracted 23 217 times. The pirates get 217 doubloons each, and 9 coins are left over. So whether you're dividing up chocolate or chests of treasure, chunking's worth checking out. Cheerio.